Assalamu alaikum, dear students. We're back with another video lesson. If you remember in the previous lesson, we talked about angular displacement. And of course, angular displacement was the arc length divided by the radius. Today we'll continue with section 1.1, of course. And today we'll talk about angular speed. And later on, of course, we'll talk about angular acceleration if we have time. All right, now, angular speed. If you remember, you've studied speed or velocity in grade 11, okay? So what is velocity? All right, so in grade 11, you studied that velocity equals to delta x over delta t, all right? And of course, it was measured in meter per second. And of course, velocity, we could have said, or the definition was that the rate of change of displacement, right? Or delta x divided by delta t, and it was measured in meter per second. And also, velocity was a vector quantity. It was in the same direction as the displacement. And of course, but in trajectory motion, if the motion was upward, we were considering velocity to be positive, and if it was downward, we were considering it to be negative. This here, because we're dealing with angular displacement, and of course we have angular velocity. What is angular velocity or angular speed? All right, angular speed, all right, we use the letter omega for that, and of course this equals to change in angular displacement divided by the time, right? So angular speed, change in angular displacement divided by the time. And of course it is measured in radian per second. All right, and of course, but I would like to tell you there is a slight difference between angular speed and angular velocity. Angular velocity is a vector quantity while angular speed is not a vector. I wish there were a bigger difference, or I wish there was, like the book has mentioned this or emphasized on this a lot, but sadly there is none. So, but for you, don't worry, there's no concern for you. If directions were mentioned or concerned, you can go along. If not, you can just use the equation, and of course you will find angular speed. All right, so angular speed, now we can say in terms of in the direction, or if I define angular speed before the direction, how would you define this? Remember this, you don't have to memorize definitions a lot, as much as you need to translate equations and convert it into a definition. For example, now, whenever something is divided by the time, can we say the rate of? Yeah. So we can say angular speed is the rate of change of angular displacement. And of course, it is measured in radian per second. That is one definition. And another definition we can say is the rate at which a body rotates about a specific or about an axis. The rate at which a body rotates about an axis. All right, so now let's talk about the direction of velocity or angular speed here. All right, now remember this. Let's say this is 12, 3, 6, and 9. If the motion is clockwise, and of course we know this, previously we've mentioned the arc length, right, the angular displacement, and also omega, which is the angular speed or velocity here, because we're concerned with the direction, so in this case these are considered negative. But if the motion is counterclockwise, all right, in this case, the arc length, angular displacement, and of course the angular velocity here, these are all considered to be positive. These are all considered to be positive. Okay, so now angular velocity, once again, it is the rate, or the angular speed, of course, it's just the magnitude of angular velocity, is the rate at which a body rotates about a specific axis, or it is the rate of change of angular displacement measured in radian per second. Excellent. Now, angular acceleration not always given in radian per second. So remember this. Or I can say angular speed sometimes is given in let's say radian per second. sometimes is given in radian per second, sometimes can be given in, let's say, rev per second, sometimes can be given in revs per minute, some other times can be given in revs or revolutions per hour, some other times can be given in revolutions per day. Or one more unit for angular speed, it sometimes could be given, instead of revolution, could be given in degrees per second. You don't see this like often, but still, just for you to know. But remember this, we cannot use, like regardless to radian per second, if these are given in equations, you have to convert them to radian per second, then you can use them. Otherwise, you cannot use these directly. All right, so if these are given, except then the radian per second, you have to convert this to radian per second. Then, of course, you can use them in questions. Right? You can use them, or they can be used in calculations. Okay, but how do we convert each one of these? All right, now take a look. If we have, let's say, revolutions per revs per second, let's say. All right, revs per second. Now, how do you convert this to radian per second? Now, you can write it down like this. So, revolution, or 1 rev per second, you know that each revolution is, what is each, or in radian? 1 revolution is equal to 2 pi radian. So, instead of this, we can say 2 pi radian divided by 1 second, of course. Yeah. All right. What if it is given in revolution per minute, let's say. So once again, 1 rev, right? And 1 minute equal to how many seconds? Equal to 60 seconds. So we can divide 1 rev by 60, or 1 minute first, of course. 1 minute equal to 60 seconds, and you know that 1 rev equal to 2 pi radian, right? And 2 pi radian divided by 60 seconds. And of course, you can do the calculation. All right, and then you can find the answer in what? In radian per second, of course. And then what if it is revolution per hour? Rev per hour, you will do the same thing, yeah? Of course, that equals to, we can, if I do it quick, that is 2 pi radian divided by 1 hour. You know that 1 hour equal to 3,600 seconds, or 3,600 seconds. And of course, once you divide the two, you get the answer in radian per second. What if it is revolution per day? Okay, if it is revolution per day, that is going to be 1 rev equal to 2 pi divided by 1 day. There are 24 hours in 1 day. So 24 times 3,600 seconds. Okay, now what if it is, for example, like revolutions could be, let's say, per day, or even per year. Yeah, we have a revolution per year as well. For example, when the Earth revolves about the sun, it completes 1 complete revolution. Of course, if this is the sun, right, and it completes 1 revolution in 1 year. So, how to convert this one to, or this angular speed here? Okay, we can say, of course, we can say angular speed equal to 1 rev, okay, divided by the time, and the time is 365.25 days. Okay, now you can convert this one into, let's say, radian per second, and of course that is going to be 2 pi divided by 365.25. multiplied by each day is 24 hours, and each hour is 3,600 seconds. Now you can divide the two, and of course you get this radian per second. All right, now since you know how to convert these, let's say these angular speed in one form to another, remember these forms has to be converted into radian per second only, then you can use them in calculations. Okay, so take a look here. If I go quick over these, speed, translational speed I've mentioned, equal to delta x over delta t. And of course we have angular speed. Basically that is our main topic, which is we use omega, or average angular speed. that is the change in angular displacement divided by delta time or delta t. All right, and then remember this, angular speed describes how quickly the rotation occurs, yeah? Like how fast it can spin about something. Angular speed can be given in radian per second, revolution per minute, revolution per hour, or revolution per day, like I've mentioned. If not given in radian per second, you have to, or they should be converted to radian per second, then we can use them in calculations. Remember, angular velocity is a vector quantity. Angular speed is the magnitude of angular velocity, and of course has the same direction as the angular displacement. This is how we can convert rev per second, rev per minute, rev per hour. You could do the rest on your own. Remember this, we said angular velocity is negative when the movement is clockwise, right? So when the movement is clockwise, the angular velocity is going to be negative. If it is counterclockwise, of course, it's going to be positive. Okay, so here you can see the direction, and of course you can add this to this as well. When the movement or motion is clockwise, we can say the arc length, the angular displacement, these are all negative, and of course the arc length, if it is counterclockwise, the arc length is positive, angular displacement is also positive beside the angular velocity here. Okay, now let's solve a few questions here. All right, take a look at this one. It says dash is the rate at which a body rotates about a fixed axis here. The rate at which a body rotates about a fixed axis and usually expressed in radian per second. And what is measured in radian per second? And that is, of course, angular speed in here. Excellent. Now, let's take a look at the second one. It is the time rate of change of angular displacement. Once again, that is angular speed. All right. Now, we have another question which is also very important to know. Take a look. It says 420 revs per minute is equal to dash rad per second. So what you are being asked is simply convert 420 revolution per minute to radians per second. Let's see. All right? Can you try this on your own? That would be great if you could do that. So I'll do it here. So of course, 420 multiplied by, remember this, each revolution, can I just like do it short? Each revolution is what? So one revolution is equal to 2 pi radian, and of course, each minute equal to 60 seconds, correct? So of course now you can simplify this too, all right? And of course, you can use your calculator. The answer is going to be 14 pi, and of course the answer is going to be option B here. Excellent. Now, one more question that says the time rate of change of angular displacement. You see, the time rate of change of angular displacement, again, that is angular speed. Okay, now, second question in chapter review says distinguish between linear speed and angular speed. What is linear speed, if you remember? Linear speed is the rate of change of distance or displacement divided by the time, while angular displacement, you can say, or the distance traveled per unit time. And then for angular speed is basically the rate at which a body rotates. That's one, or you could say the rate of change of angular displacement divided by, or the rate of change of angular displacement, because when we say the rate of, that means divided by the time already. So angular or linear speed is measured, or it is measured in meter per second, while angular speed is measured in radian per second. All right, now let's move on. We have a sample problem. Sample problem A says Zhyar spins on a stool in a counterclockwise. Remember, because the direction is given here, so you have to consider the direction. It is counterclockwise, which means the arc length, the angular displacement, and omega, or angular velocity, these are all considered to be negative, with an average angular speed of 4 radian per second. In what time interval will Zhyar's feet have an angular displacement of 8 pi radian? All right, take a look here. let's solve this question. All right. Okay. Let's make it white. All right, it says, so what we have is this, an average angular speed. So we have omega, that is basically negative 4.0 rad per second, or radian per second. And then in what time interval, so find delta t, okay, find delta t. Will Zhyar's speed have an angular displacement? So we have angular displacement, once again negative. That is because it is rotating clockwise. It is 8.0 pi radian. All right, so how to find this? We know that angular displacement, all right, or angular speed equal to, of course, change in angular displacement divided by delta t. Find delta t, of course, you can swap this too. So delta t equal to change in angular displacement divided by angular speed. In this case, is going to be negative. Of course, these are both negative. So angular displacement is going to be negative 8 pi divided by 4 pi radian. These are both negative. 4 pi, so of course, you can divide 4 radian. This is 8 pi, 8 pi, of course, 4. All right, so this is in radian. This is a radian per second. Of course, the negatives cancel each other out. So 4 divided by, or 8 divided by 4. I don't know, what am I saying? All right, so 4 divided by, again. So 8 divided by 4, of course, that is 2. So it's going to be 2 pi, right? 2 pi second. But of course, you can convert this into each pi is 3.14. So can we say that is going to be 6.28 seconds. Yes, and remember, delta t or time can never be negative, yeah? Because that's all. If it is negative, that is also almost like going or moving, going backward in time, which you know that it is impossible, at least for now. Okay, so now the answer is going to be what? It's going to be 2 pi second if you're given as a multiple choice. Let's say whenever you see 2 pi second, of course you can choose that, or you can convert 2 pi into 6.28 seconds. Okay, now we have, you can see, all right, that is basically by rounding it up. Of course, you can say it is about 6.3 as well. All right, now practice 1b. It says a car tire rotates with an average angular speed of 29 radian per second. That is the angular speed. In what time interval will the tire rotate 3.5 times? The idea of this is very close to the other one with a slight difference here. Let me tell you what is the difference. The difference is this. It tells you the tire rotates 3.5 times. 3.5 times. This is angular displacement. When it says, so we have the tire. If it rotates 3.5 times, so watch this. This is 1. Can I call it 1 rev? Yes. This is 2 times. That is 2 rev. This is 3 times, and this is 1/2. Yeah. So 3.5 times is basically telling you 3.5 revolutions. All right. Now, of course, we can after this, or after you know this, you can easily solve the rest. We can solve together here. All right, let me get a rectangle. Let's change this one to white. Now we can solve this. Once again, we have angular speed, which is 29 radian per second, or rad per second. In what time interval? As you can see here, the direction is not mentioned here, so you don't have to worry about that. And of course, the angular displacement is 3.5 times. I can say 3.5 revs, yeah? And find what? Find the time it takes, yeah? So now let's convert this one here, 3.5 revs. You know that each revolution equal to what? How many pi radian? Equal to 2 pi radian, yeah? So 3.5 times 2 pi radian. And of course, you know that 3.5 times 2 is going to be 7 pi radian. I don't believe now you can you can finish, or you know how to do, or continue, or complete the question now. All right, but still, we can say, let me use black this time. All right, so delta t equal to angular displacement divided by the angular speed. So in this case, it's going to be angular displacement is going to be 7 pi radian divided by 29, and that is, of course, rad per second. And of course, now you can find the answer. The answer is going to be in second. All right, so what is the answer now? You can see the answer is going to be 0.76 seconds. Okay, great. Now, moving on, there's another question says, a car rotates with an average angular speed of 22 radian per second or rad per second. In 1 second, the car tire will make this much rotation. You can see all these are given in radian. This is interesting, by the way. So what I want you to know is this. Angular, basically we're trying to find the number of revolutions. So angular displacement, correct? Because you're given the angular speed, you're given the time, so find angular displacement. But then the angular displacement you're going to find is going to be in radian, yeah? But then you can see all the options are given are in revolutions. So you have to convert this into revolutions. All right, so take a look. We can say angular speed equal to angular displacement divided by the delta t. Now here delta t equals to, we're trying to find the angular displacement. All right, so angular displacement equal to angular speed multiplied by delta t. And of course that is 22 multiplied by 1. And of course equal to 22 radians. But we don't want radians, you have to convert it into revolutions. Now we can say, like if I do it quick, we know that each revolution is 2 pi radians. So if I divide this by 2 pi radians, so 22, or theta in revolutions you can say, equal to 22 divided by 2 pi radian, and of course that is what is going to be, use a calculator, you will get the answer there, yeah? Let me get a calculator. Okay, that is basically 22 divided by 2 pi radian. So 22 divided by 2 pi radian, and of course the answer is going to be 3.5 revolution, and that is the answer, 3.5 revs, yeah? And of course that is going to be option C. All right, very good. Now let's move on. It says fill, okay. We have another question. It says fill in the unknown quantities in the following table. I'm not going to do A, B. Perhaps I'll do C because there is a revolution, and then the rest you can do them on your own. All right, so let's take a look at this. But I'll tell you how you can do them. First of all, let's say number 1, if angular speed is not given, you can use this. Angular speed equal to angular displacement divided by delta t, that is 1. If angular displacement is not given, of course angular displacement equal to angular speed multiplied by delta t. And then the third one, if time is not given, or if time is not given and it has been asked, so we can say delta t equals to angular displacement divided by the angular speed. So I'll do, you can try A and B. I'll do C for you. So take a look at part C. Says find the angular speed, but theta is given in revolutions. Can we use revolution in calculations? No. We have to convert revolutions first, and then we can use them to find the angular speed. All right, so let's solve this. First of all, we can say angular speed equal to angular displacement, that is part C, don't forget, divided by change or delta t. So what we have is negative, so negative 1.2 revs or revolution divided by 1.2 second. So remember this, each revolution is equal to 2 pi radian. I believe by now, you know you know how to convert this. So instead of this revolution, can I say 2 pi radian? Yes. Now all you need to do is just simplify the two. So this 1.2 cancels out with 1.2, so we're left with negative 2 pi radian. Okay, negative 2 pi radian. So the answer is going to be angular speed is negative 2 pi radian. And of course, if this is given in the option, that would be great. If not, you can change this negative 2 pi to numbers only. And of course, 2 times 3.14, 3.14, that is going to be negative 6 point, what am I writing here? 6 point, okay, oops, that's thing we cannot go back to this now. All right, so let's see if we can make it back. All right, let's see. I think it's too late to go back. Or anyway, so the answer was negative, so angular displacement was negative 2 pi rad per second. I don't know if I wrote watt per second before, but you convert 2 pi into numbers only. 2 times 3.14, that is going to be negative 6.28, that is watt per second. This is the answer to part C. All right, and of course, this one here, I believe you can easily do this, so I'm not gonna do that for now. All right, there is another question that says calculate the unknown. I believe these are simple enough. We have angular speed, there is angular displacement, find the time. You can use this equation to find this. So delta t equals to angular displacement divided by the angular speed. You plug in the numbers and then calculate, and then of course you'll find the answer. And of course the answer is going to be what? That is basically, it is A, yeah? So it has to be 0.75 seconds. If not, then recalculate, see what went wrong. All right, take a look at this one here. That's also another interesting question here. It says, a bicyclist rides along a circular track. If, remember this, if the bicyclist travels around exactly half the track. So what does half the track mean here? Right, so let's see. Okay. All right, so half the track. What does half the track means here? So half the track, that means if there is a circular path you can see here, half the track, that means only this much. So you know that one track equal to one revolution, and that is equal to 2 pi, of course, yeah? But if it is half a track, it's going to be half a revolution, as you can see, only half a revolution. Let me erase the other part. All right, so half a revolution, and half a revolution clearly equals to 1 pi, 1 pi. If one full circle is 2 pi, half of it is going to be 1 pi. So of course, now I believe you know the rest, but let me do it still. All right, so it says what is the average angular speed? So average angular speed here, you can say average equals to change in angular displacement divided by the delta time, or delta t. Delta t here, it is 10 seconds. So half a track is going to be pi, right? Remember, you have to use pi radian, right? Divided by 10 seconds. Now you calculate, and of course you can get the answer, and that is going to be 3, or we can say pi is basically equal to 3.14 radian divided by 10, and of course now it's going to be 0.314, because it is angular speed, is going to be radian per second. Excellent. So the answer is going to be A. Okay, now another part here. It's the same thing, but instead of having half a circle, of course, we have a quarter, or 1/4 of the path. 1/4 of the path, that means angular displacement, right? Delta theta is going to be 1/4. That is because quarter, you know that quarter is 1/4. All right, now, I would like to emphasize on something different, which is also very important, right? Now, take a look at this. Angular speed is constant for the following cases. Whenever the motion of something doesn't change of course, we say angular speed is constant. For example, and what are these things? The angular speed for the second hand, for the minute hand, for the hour hand, for the Earth's rotation and Earth's revolution is constant. And also we can say the angular speed for the revolution of the moon about the Earth is also constant. Now let me show you something. All right. So for example, we have this clock, right? So take a look. Here, if you can see, we have, for example, the second hand. In order for the second hand, I hope you can see well, in order for the second hand to complete, you can see that it doesn't speed up or slow down, yeah? Unless if the battery is dead or dying, that's a different story. But still, if the clock is working well, right, you can see that for the second hand to complete one revolution, it takes 60 seconds, right? So let me take you to this. For the second hand, we can say the angular speed for the second hand is constant, and that is because we know that angular speed equal to angular displacement divided by the delta time. All right, so if it is the second hand, you know that it completes one revolution, one rev, right, in 60 seconds. Okay, so of course we can say 60 seconds. Now, one rev, that is 2 pi radian divided by 60 seconds, and of course you can find the answer, which I'm going to tell you now. Then now, take a look at the minute hand this time. You can see that. It's the one that is, for example, this one. For the minute hand to complete one revolution, it takes what? Is it 60 seconds? No, it is 60 minutes. Yeah, take a look here. For example, if it is, let's say it is 11 now. In order for, watch the minute hand. So for the minute hand to complete one one revolution, you can see, how many minutes will it take? That is 5, 10, 15, 20, let's say that is 30. I hope I'm holding it correct. All right, so this is 30 minutes, of course, 45 minutes, and this is 1 hour. Can I say the time it takes for the minute hand to complete one revolution is 60 minutes? Yes, well done. What about for the hour hand? You can see the shortest hand here. In order for the hour hand to complete one revolution is 24 hours? No, that is, if you say 24 hour, remember that is 1 day. Okay, so you can see it goes or starts from 1, 2, and then it completes one revolution at 12. So remember this, the hour hand makes one complete revolution in 12 hours, not 24. All right, I think we're done with this. That was good. So take a look here. We can say the value, or these values are, let me take you to a new page. The value, or these values are the angular speed, if I say, the angular speed is constant for the following, let's say for the following cases. Is constant for the following cases, yeah? For the following cases. Take note, all right? Now the first one is the second hand, yeah? The first one we can say second, all right? The first one is second hand, all right? Now, the next one is the minute hand. The third one is the hour hand, all right? And then fourth one we can say Earth is rotation. Earth is rotation. And then Earth is, the fifth one, Earth is revolution. Earth is revolution. And of course we can say the moon's revolution as well. But how do we know the angular speed of each one of these, right? You don't need to memorize the whole thing or the speed of each, right? All you need to know is, because during the exam, of course, you would would have been memorized, I don't know, like hundreds of equations and of course of numbers, definitions. So it will be a little bit hard to remember the value of each. Yeah? But I'll tell you one thing, you try or you do this, the rest you can easily remember. So for the second hand, we can say angular speed equal to, remember we said the second hand completes for the second hand, all right? Second hand, it completes one revolution in 60 seconds, right? So now one revolution, that is 2 pi radian divided by 60 seconds. And of course that is equal to 0.15, that is radian per second. All right, now what about the next one? Let me just double check this. 2 pi divided by 60, and of course it is about 1.047 by rounding, of course, equal to 0.105 radian per second. What about for the minute hand? Yeah, you will do the same thing. You will just change the time it takes to rotate. Yeah, so for the minute hand, we can say 1 rev divided by the time it takes. Remember, for minute, for the minute hand, it takes 60 minutes, yeah, or 1 hour to complete one rotation. So we can say 2 pi radian divided by 60 minutes times each minute is 60 seconds. Of course, we can say it is 3,600 seconds. Now you divide the two, of course, it is equal to 2 pi radian divided by 3,600, that is about, let's say, 1.74, or we can say 75, of course, multiplied by 10 to the power -3 radian per second. Remember this, these answers, you don't need to remember them. As long as you know this, for example, for the second hand, it takes 60 seconds to complete one revolution. What about for the minute hand? It takes 60 minutes, yeah? So of course you convert minute into second. What about the hour hand? It takes 12 hours to complete one rotation. I'll skip the hour hand because that you can do them. What about for the Earth's rotation and revolution? You know that Earth completes one rotation or one spinning on its axis in, let's say, in 24 hours, yeah? So of course we can say the angular speed for Earth's rotation equal to one revolution in 24 hours. So that is going to be 2 pi radian, because each revolution is 2 pi, 24 hours. So 24 multiplied by, you know that each hour is 60 minutes and each minute is 60 seconds. So of course we can say each hour is 3,600 seconds, right? You multiply and or simplify and then divide. Of course you will get the answer, and that is going to be 2 pi divided by 24 times 3,600 seconds. Of course, the answer is going to be, let's see if we can convert this to scientific. All right, so we can give you this. So, of course, the answer is going to be, so angular speed for Earth's rotation is going to be 7.27 multiplied by 10 to the power -5 radian per second. Okay, what about Earth's revolution, yeah? In order for Earth to complete or to make one complete rotation about a revolution about the Earth, if I erase this, all right, in order for the Earth to make one, right, so this is, let's say, Earth, this is the Sun. In order for the Earth to make one complete revolution about the Sun, of course, it takes 365.25 days, yeah? That is the time. But of course, you can't use that. You have to convert the days into seconds. All right, so take a look. Oops, something unwanted. So we can say 1 rev divided by delta t, or we said the time it takes is 365.25 days, yeah? But you can't use days in calculation. So 1 revolution, that is 2 pi radian. And of course, 365.25. Each day is 24 hours, and each hour is 3,600 seconds. Now, you can calculate this, all right, and the answer is going to be, I forgot my calculator, but still 2 pi divided by 365.25 times 24 times 3,600 seconds. And of course, the answer is going to be 1.99 times 10 to the power negative 7. 1.99 times 10 to the power negative 7. Negative 7 what? Watt per or radian per second. Okay, what if it is the revolution of the moon about the Earth? First of all, they should tell you how long does it take moon to complete or to make one complete revolution. Is it 28 days? Is it 29 days or even 30 days? Yeah? And then you have to convert the days into hours and then into seconds, let's say, or in seconds in general. So 1 rev or 2 pi divided by, let's say, 29 days. 29 times each day is 24 hours. Each hour is 3,600 seconds. And of course, you will find the answer or the angular speed of the moon's revolution about the sun. So take a look. You can see the time it takes the second hand. Once again, 2 pi over 60 seconds. Here is the answer. The time it takes the minute hand to complete, let's say, 1 revolution, that is 60 minutes, which is 3,600 seconds or 3,600. So that is 1.75 times 10 to the power negative 3. The time it takes for the hour hand, once again, remember it completes 1 revolution in 12 hours, not 24. If it is a 24, then that is going to be 1 day. And of course, it is not 1 day. Okay. The time it takes the Earth to complete 1 rotation about itself is 24 hours. So 2 pi divide this. Here's the answer. The time it takes the Earth to complete 1 revolution, that'll be 1 revolution about the sun, is going to be 365.25 days. You just convert this one to days and then to seconds. You divide the two, then of course you'll get 1.99 times 10 to the power negative 7. Take a look at this question. It says, how long does it take the second hand of a clock to move through 4 radian? All right, watch this. So we've mentioned earlier, let's use this, okay. All right. Okay, so stay with me. The first thing we have says, how long does it take the second hand? So what is not given or what has been asked is delta t, right? It says for the second hand of a clock, remember this, because it talks about clock or second hand of a clock, if you mention the direction, that is going to be negative because you know that the second hand is going to move clockwise, correct? So that is a negative. Okay, so it says to move through 4 pi radian. That is basically angular displacement, which is 4 or negative 4 radian. Okay, now, but in order to calculate the time, what do I need? Right, I need delta or angular speed, you know, right, equal to angular displacement divided by the time. In order to find the time, delta t equals to angular displacement divided by angular speed. But do I have angular speed? No. But we've just mentioned that the angular speed of the minute hand, of the second hand, of the hour hand, of Earth's rotation and revolution, these are all constant. So don't expect this number or the angular speed of the minute hand to be given. You have to know it. So how do you find it? Let me see if I saved any space here. But okay, I can do it here. So we can say angular displacement of the second hand is going to complete 1 rev in 60 seconds. 1 rev, that is 2 pi radian, in 60 seconds. All right, so of course you can divide the two, that is going to be 0.105 radian per second. Okay, now you can write this into the calculation. But of course, this is going to be negative because these are clockwise. So we can say negative 4 divided by 0.15, and of course, you can find the answer, which is going to be, or equals to, let's see, negative 4 divided by 0.015. The answer is equal to 3.8 or 38, you can say, right? So in this case, it's going to be, of course, these negative cancel out, or you can say these two are both negative. So the answer is going to be 38 seconds, of course. Okay, remember, time must be positive always. Of course, you can say about 38.1 as well if you would like to be more precise. Take a look at this. Find the average angular speed of Earth about, let's say, about the Sun in radian per second. Remember that Earth orbits the Sun once every 365.25. I think I've done this, so I'm not going to go through this. First, you can convert the time from days into seconds. All right, and then after that, 1 rev divided by this time in second. 1 rev is 2 pi, so the answer is going to be 1.99 times 10 to the power negative 7. All right, there are other questions. I'm not going to do all of it, but perhaps I'll do one of these, yeah? It says, the first one here, perhaps you could do the rest on your own. It says what? Earth rotates 360 degrees every 24 hours, okay? Now, what is the angular displacement of a person standing at the equator for 3 hours, yeah? So find the angular displacement of a person. So delta time is given, which is 3 hours. But remember this, it says Earth rotates 360 degrees every 24 hours. Isn't that one rotation in 24 hours? Okay, so 360 degrees is equal to 1 revolution. Or in another way, isn't that equal to 2 pi radian? Yes. So now this basically is given to find angular speed. And then once you find angular speed, of course, you have time, you can find delta t. All right, so let's do each one of these at a time. So first of all, let me do or find the angular speed first. For this, then we can use the answer to find the angular displacement. So if I do it here, angular speed for the Earth, all right, is going to be 360 degrees. That is 2 pi, 1 revolution, radian, in 24 hours. Convert 24 hours into seconds. So 24, each hour is 3,600 seconds. So the answer is going to be 2 pi, all right, divided by 24 times 3,600. That is about 7.27 times 10 to the power negative 5. That is radian per second. This is the angular speed of Earth's rotation. Next, what is the angular displacement? Yeah. So angular speed again, right? Angular speed equals to angular displacement divided by the time. So angular displacement equal to angular speed multiplied by the time here. So angular speed we found, which is 7.27 times 10 to the power negative 5 multiplied by 3 hours. Remember, 3 hours, 3 times 3,600 seconds. Yeah. Now you can multiply the two, and of course you will find the answer. Let's see. All right. So the answer is going to be this multiplied by 3 hours. Each hour is 3,600. All right. So the answer is going to be 7.85 times 10 to the power negative 8, or 0.76, you can say, yeah? 0.776, or perhaps if I cancel some of these, the answer is going to be 0.79 here. All right, let me double check. Okay, so 7.27 multiplied by 10 to the power negative 5, right? Multiplied by 3, multiplied by 3,600, and of course the answer is going to be 7.85, which by rounding, of course, you will get 7.9. So 0.785, or by rounding, it's just going to be 0.79, and that is radian. Okay, that's all for today. You can, by the way, you can solve the rest of the questions. I believe these are pretty easy. With a little bit of practice, of course, you could do them very easily. Next lesson, inshallah, we'll talk about angular acceleration and the variation of angular speed. Until next lesson, keep practicing. I'll see you next time.